Okay, the figures are similar. We're going to give the ratio of the perimeters, and we're going to give a ratio of the areas. Now, the ratio of any particular length is going to be the ratio of all lengths. What do I mean by that? Well, what I mean is that if we take this ratio from the smaller one to the bigger one of 32 to 36, and we simplified that, dividing them both by the biggest thing we can divide by, which is 4, we would get 8 to 9, okay? Since they have side length ratios of 8 to 9, then their entire perimeter is going to be an 8 to 9 ratio as well. So you can see that that is there at on answer A and answer D. That's how they start at 8 to 9, okay? Now, of course, whenever we want to find out the ratio of their areas, we take those two values that we had 8 to 9, and we simply square them. 8 squared to 9 squared. What is 8 squared? 64. What is 9 squared? 81. And we see that here on A. So the answer is A. Okay, there's side length ratio, which means any lengths, including perimeter, will have that same ratio. We just need to simplify it. That's 8 to 9. And then square them for the areas, because area is units squared. So let's do that again. The widths of two similar triangles are 24 yards and 27 yards. What's the ratio of their perimeters and areas? Well, 24 to 27 simplifies by 3 down to 8 to 9. What do you know? Okay, and what's the ratio of their areas? Same thing. You're going to square it. And so we have the exact same answer for number 3 as we did for number 2, which is an 8 to 9 ratio, which then, when squared, becomes a 64 to 81 ratio. And that's what we've got right there.